A structure is like a custom recipe that tells the compiler how to group several different pieces of data together, just as a recipe groups flour, eggs, and sugar into one cake batter. In C, the syntax starts with the keyword struct, followed by an optional tag name, a pair of braces containing member declarations, and a terminating semicolon. Example, struct point opens brace int x semicolon horizontal coordinate in y semicolon vertical coordinate close brace semicolon. The semantics are that each member has its own type, and offset inside the memory block that will hold a point. The tag point can later be used to refer to this layout, but the tag itself does not create any storage, it is just a blueprint. The compiler also enforces that each member is declared with a type it understands, and it decides how much space each needs based on the platform's data model. For example, int might be 4 bytes. Once the blueprint exists, you can declare a variable that follows it, initialize it with a starting value, and later assign a new value. Declaring is like buying a specific toolbox that follows the recipe struct point p1. Initialization can be done at the point of declaration using a brace enclosed list struct point p2 equals brace 3, 4 brace. If you omit the initializer, the members contain indeterminate garbage values until you set them. Assignment copies the whole block, similar to swapping one filled toolbox for another p1 equals p2 copies both x and y. You can also assign individual members p1.x equals 10, p1.y equals 20. In C99 and later, you may use a designated initializer for clarity struct point p3 equals brace.y equals 5, .x equals 2 brace. The order does not matter, just as you could pack ingredients into a bowl in any sequence. A nested structure is a structure that contains another structure as one of its members, like a toolbox that itself holds a smaller toolbox. This lets you model real-world entities that have subparts. Struct date open brace int year, month, day semicolon close brace. Struct employee open brace char name open bracket 30 close bracket semicolon struct date birth semicolon double salary semicolon close brace. Here employee contains a date named birth. You access nested members with the dot operator twice. emp.birth.year equals 1990. A structure array is an array where each element is a whole structure, useful for collections of similar objects, for example, all students in a class. Struct point points open bracket 5 close bracket semicolon points open bracket 0 close bracket equals open parenthesis struct point close parenthesis open brace 0, 0 close brace semicolon. Combining both gives powerful models. An array of employee where each employee has a nested date. This mirrors a spreadsheet where each row employee has columns name, birth date, salary. Explanation: when you give a structure to a function, you have two choices: by value copy or by reference share the original. Passing by value creates a duplicate of the whole structure on the stack, like making a photocopy of a document before handing it to someone. Void print point open parenthesis struct point space p close parenthesis open brace print open parenthesis quote open parenthesis %d, %d close parenthesis backslash end quote p dot x p dot y close parenthesis semicolon close brace. Calling print point open parenthesis pt close parenthesis copies pt. This is safe because the function cannot modify the caller's data, but it can be costly for large structures. Passing by reference uses a pointer analogous to handing over the original document, so the receiver can edit it directly. Void move point open parenthesis struct point pointer p, int dx, int die close parenthesis open brace p arrow x plus equals dx semicolon p arrow y plus equals die semicolon close brace. You call move point open parenthesis ampersand pt, 5, minus 3 close parenthesis. The function receives the address of pt and can modify its members. The downside is you must ensure the pointer remains valid for the duration of the call, no dangling pointers. A structure pointer stores the memory address of a structure variable. When the structure size is unknown at compile time, or when you need many instances, you allocate memory dynamically with malloc uninitialized or calloc 0 filled. This is like renting a storage unit for a toolbox you might need later. Struct point star p equals malloc open parenthesis size of struct point close parenthesis semicolon allocate. If open parenthesis p close parenthesis open brace p arrow x equals 1 semicolon p arrow y equals 2 semicolon print open parenthesis %d, comma %d backslash, and close parenthesis, comma p arrow x, comma p arrow y close parenthesis semicolon free open parenthesis p close parenthesis semicolon release close brace. Calloc would be used as calloc open parenthesis 1 comma size of struct point close parenthesis. Dynamic allocation lets you create arrays whose length is decided at runtime struct point star list equals malloc open parenthesis n times size of star list close parenthesis semicolon. Remember to free the memory, otherwise you leak resources, just like leaving a rented storage unit unpaid forever. Structures are perfect for mathematical objects because they bundle the components of a vector matrix or complex number together. Vector. Typedef struct double x double y double z vec3. Vec3 add takes vec3, and when vec3b returns a new vec3 with components a dot x plus b dot x, a dot y plus b dot y, a dot z plus b dot z. The addition follows the mathematical rule C equals a plus b, where C sub I equals a sub I plus b sub I. Matrix a 2x2 matrix can be stored as a nested array, or as a struct of arrays using a struct gives named access. Typedef struct double m2x2 mat2. Mat2 mul takes mat2a, and mat2b defines mat2 are initialized to 0 3 nested loops over ijk from 0 to 2 update r dot mij plus equals a dot mik times b dot mkj finally return r. The triple nested loop implements the formula r sub ij equals the sum over k of a sub ik times b sub kj. Complex number. Typedef struct double ray double im complex. Complex mul c takes complex, and when complex b returns complex with real part a dot ray times b dot ray minus a dot im times b dot im, and imaginary part a dot ray times b dot im plus a dot im times b dot ray. This mirrors the algebraic rule a plus b I times c plus d, I equals a c minus b d plus a d plus b c I. Using structs keeps the code readable and groups related data, just as mathematicians keep real and imaginary parts together. Explanation. Exam questions often test whether you can translate a description into a correct struct definition and then manipulate it. 1. Define a struct for a student with fields ID integer, name char50 and GP a float. 2. Write a function float average GP, a struct student pointer list integer n that returns the mean GPA. 3. Create an array of n employee structs using malloc, fill it with data read from input, and then free the memory. 4. Implement a swap function that exchanges 2-point structs passed by pointer. 5. Explain why passing a large struct matrix by value may cause a stack overflow, and rewrite the prototype to use a pointer. These questions require you to demonstrate understanding of declaration, initialization, pointer usage, and memory management combined with clear bug-free code. A structure in C is a plain collection of data, whereas a class in C++ or a record in Pascal or C# adds extra features such as methods inheritance and access control. Scope, a struct type defined at file scope, is visible to all functions after its definition, similar to a global blueprint. If defined inside a function, it is local to that block, just like a temporary recipe you can only use inside a kitchen. Classes can have public, private, and protected sections controlling who sees what. Lifetime, variables of struct type follow normal variable lifetime rules. Automatic stack for local variables, static for globals, dynamic when allocated with malloc. A C++ class may have constructors and destructors that run automatically when an object is created or destroyed, managing resources such as opening a file. Memory layout. In both structs and plain old data pod classes, members are laid out in the order they are declared, possibly with padding for alignment. See later. However, C++ may add hidden members for virtual tables VPTR when the class has virtual functions making its size larger than the sum of its fields. In pure C structs, there is never such hidden data. Thus, while structs give you a lightweight, predictable memory, picture classes give you more abstraction at the cost of extra hidden overhead. Explanation: when the compiler places members of a struct in memory, it tries to align each member on an address that satisfies the platform's alignment requirement. For example, a 4-byte int should start at an address divisible by 4. To meet this, the compiler may insert padding bytes between members or at the end of the struct. This can surprise programmers when size of struct is larger than the sum of its fields. Example: struct example open brace char a semicolon int b semicolon needs 4-byte alignment close brace. The compiler will insert 3 padding bytes after a size of struct example becomes 8 not 5. If you forget to initialize members, they contain indeterminate values, leading to undefined behavior when read. Always initialize either with a brace initializer struct point p equals open brace 0, 0 close brace, or by setting fields explicitly. Another pitfall is misusing pointers to structs that have been freed or never allocated, resulting in dangling pointers. Finally, be aware of structure packing directives, for example pragma-pack, which can change padding rules. They are useful for binary file formats, but can hurt performance because misaligned accesses may be slower on some CPUs.